Chapter 1: Introduction to Web3 and the Next Generation of Developers. In this foundational chapter, participants will embark on a journey into the world of Web3, where decentralized technologies like XRPL, Algorand, and Hedera Hashgraph are reshaping the digital landscape. The chapter sets the stage by 1. Defining Web3 concepts, understanding the shift from traditional web paradigms to decentralized, user-centric models. 2. Introduction to XRPL, Algorand, and Hedera Hashgraph, exploring the unique features and capabilities of each distributed ledger technology. 3. Importance of next-generation developers, recognizing the pivotal role of developers in shaping the future of Web3 and the blockchain ecosystem. 4. Overview of training objectives, outlining the course's goals and the skills participants will acquire to become proficient Web3 developers. As the gateway to the course, this chapter aims to inspire a sense of excitement and curiosity about the transformative potential of Web3 technologies. Participants will gain clarity on the significance of XRPL, Algorand, and Hedera Hashgraph and their role in building the decentralized future. Chapter 2: Building Blocks of Web3, Understanding XRPL, Algorand, and Hedera Hashgraph. Diving deeper into the technology stack, this chapter focuses on the foundational elements of XRPL, Algorand, and Hedera Hashgraph. Key aspects covered include 1. Consensus mechanisms, exploring the consensus algorithms that underpin XRPL, Algorand, and Hedera Hashgraph, such as the Ripple Protocol Consensus Algorithm, RPCA, Pure Proof of Stake, PUZ, and Hashgraph Consensus. 2. Smart contracts and decentralized applications, dApps, understanding how smart contracts execute on each platform and their role in decentralized application development. 3. Token standards, examining token standards like XRP, Algorand Standard Assets, ASAs, and Hedera Token Service, HTS, and their use in creating digital assets. 4. Interoperability, exploring the interoperability features of each DLT and their potential to collaborate and communicate across different blockchain networks. This chapter equips participants with a technical understanding of the underlying architecture, consensus mechanisms, and features that define XRPL, Algorand, and Hedera Hashgraph, laying the groundwork for hands-on development exercises in subsequent chapters. Chapter 3: Setting up your development environment. Before diving into practical exercises, this chapter guides participants through the process of setting up a development environment tailored for XRPL, Algorand, and Hedera Hashgraph. Key topics covered include 1. Choosing a code editor, recommendations and configuration tips for popular code editors like Visual Studio Code to enhance the development experience. 2. Installing necessary tools, step-by-step instructions for installing development tools, SDKs, and command line interfaces specific to XRPL, Algorand, and Hedera Hashgraph. 3. Creating developer accounts, walkthroughs on creating developer accounts on respective platforms, obtaining API keys, and configuring accounts for development. 4. Testing environments, exploring sandbox and testnet environments provided by XRPL, Algorand, and Hedera Hashgraph for safe experimentation and testing. By the end of this chapter, participants will have a fully functional development environment, ready to embark on hands-on coding exercises and projects in subsequent chapters. Chapter 4: Introduction to XRPL Development. In this chapter, participants get introduced to the specific features, tools, and languages associated with XRPL development. The key components include 1. Understanding the XRP ledger, a deep dive into the fundamentals of XRPL, including its consensus mechanism, native cryptocurrency, XRP, and decentralized exchange. 2. Development languages, overview of coding languages used in XRPL development, with a focus on XRP Ledger API, JavaScript, and relevant libraries. 3. Smart contracts on XRPL, introduction to smart contracts and decentralized applications, dApps, within the XRPL ecosystem. 4. Hands-on coding, practical coding exercises to implement basic transactions, explore XRPL data structures, and deploy simple smart contracts. Participants will gain foundational knowledge and practical skills necessary for XRPL development, setting the stage for more complex projects in subsequent chapters. Chapter 5: Advanced XRPL Development. Building on the fundamentals, this chapter delves into advanced topics and techniques in XRPL development. 1. Advanced smart contracts, exploring complex smart contract scenarios, including multi-signature transactions, escrow, and time-locked contracts. 2. Interacting with decentralized finance, DeFi, on XRPL, understanding and implementing financial operations, such as lending, borrowing, and decentralized exchanges within the XRPL ecosystem. 3. XRPL hooks, a comprehensive guide to XRPL hooks, allowing participants to integrate custom business logic into the XRPL. 4. Cross-border payments, harnessing XRPL's capabilities for efficient and secure cross-border transactions. This chapter equips participants with the skills needed to engage in sophisticated XRPL development, opening doors to innovative applications and solutions. Chapter 6: Security Best Practices for XRPL. Ensuring the security of XRPL-based projects is paramount. This chapter focuses on best practices to safeguard XRPL applications and transactions. 1. Smart contract security, understanding common vulnerabilities in smart contracts and implementing best practices to secure them. 2. Secure key management, exploring secure methods for key generation, storage, and usage within XRPL applications. 3. Network security, guidelines for protecting XRPL nodes and ensuring secure communication over the network. 4. Transaction verification, implementing robust verification processes to enhance the integrity of XRPL transactions. Participants will gain a comprehensive understanding of security considerations, mitigating risks and ensuring the resilience of XRPL projects in a dynamic digital landscape. Chapter 7: Building Decentralized Applications, dApps, on Algorand. This chapter is designed to guide developers through the process of creating decentralized applications on the Algorand blockchain. Key topics include: 1. Introduction to Algorand smart contracts, understanding the fundamentals of Algorand's smart contract capabilities. 2. Algorand transaction architecture, exploring the structure of Algorand transactions and optimizing their design for dApp integration. 3. Algorand SDKs and tools, practical insights into the Algorand SDKs and development tools to streamline the dApp development process. 4. dApp deployment strategies, strategies for deploying decentralized applications on the Algorand blockchain and considerations for user interaction. By the end of this chapter, participants will possess the knowledge and skills needed to build robust and efficient dApps on the Algorand platform. Chapter 8: Harnessing XRPL for Cross-Border Payments. This chapter focuses on leveraging the capabilities of the XRPL, XRP ledger, for creating efficient cross-border payment solutions. Key topics include: 1. Understanding the XRPL architecture, a deep dive into the structure and mechanisms of the XRPL, emphasizing its suitability for cross-border transactions. 2. XRP as a bridge currency, exploring the role of XRP as a bridge currency and its advantages in facilitating seamless cross-border payments. 3. Integrating XRPL in payment gateways, practical insights into integrating XRPL into payment gateways for real-world applications. 4. Security considerations, addressing security challenges and implementing best practices when developing cross-border payment solutions on XRPL. Upon completion of this chapter, developers will be equipped with the knowledge to design and implement cross-border payment solutions using XRPL. Chapter 9: Algorand Smart Contracts, Beyond the Basics. This chapter delves into advanced concepts and practices related to developing smart contracts on the Algorand blockchain. Key highlights include: 1. Stateful smart contracts, understanding and implementing stateful smart contracts for more complex and dynamic applications. 2. Atomic transfers, exploring the concept of atomic transfers and how they enhance the functionality and security of smart contracts on Algorand. 3. Algorand smart contracts in DeFi, examining the role of Algorand smart contracts in decentralized finance, DeFi, applications and protocols. 4. Real-world use cases, showcasing real-world examples of innovative smart contract applications on the Algorand blockchain. Developers will gain practical insights into elevating their smart contract development skills on the Algorand platform. Chapter 10, Hedera Hashgraph, Building Scalable and Secure dApps. This chapter focuses on decentralized application (DApp) development on the Hedera Hashgraph distributed ledger technology (DLT). Key topics covered include: 1. Hedera Consensus Service (HCS), understanding the unique consensus mechanism of Hedera Hashgraph and its applications in building secure dApps. 2. Smart contracts on Hedera, exploring the scripting language and capabilities for developing smart contracts on the Hedera network. 3. File service and tokenization, leveraging the file service for storing large datasets and tokenizing assets on Hedera. 4. Interoperability with other DLTs, understanding how Hedera Hashgraph can be integrated with other DLTs for enhanced functionality. Developers will gain insights into harnessing the features of Hedera Hashgraph to create scalable and secure decentralized applications. Chapter 11, Holocane Development, Peer-to-Peer Applications in a Post-Blockchain Era. This chapter dives into the innovative world of Holocane, a unique framework for building peer-to-peer applications. The key elements covered in this chapter are: 1. Agent-centric architecture, understanding the agent-centric paradigm of Holocane, where each user has their own chain. 2. DHT, distributed hash table, exploring how Holocane uses DHT for data validation and storage in a decentralized manner. 3. Conducting transactions without global consensus, learning how Holocane avoids the need for global consensus, enabling more efficient and scalable applications. 4. Building HAPS, Holocane applications, practical insights into developing decentralized applications using Holocane's framework. Developers will gain a profound understanding of Holocane's unique approach and the tools required to develop robust peer-to-peer applications in the post-blockchain era.